Hello everyone, this is Alex Masichev with Intwillion. Welcome to our webinar today. Um, we are going to talk about one of the hottest topics in the content industry, chatbots. We'll discuss what makes many of currently existing chatbots difficult to scale and outline an approach that can help us build chatbots that will be more scalable, more helpful, and more knowledgeable. I hope everyone can see my screen. If you cannot see my screen, please write it down in the chat window. A few housekeeping notes before we begin. We are recording the webinar and the recording will be available to you shortly after this session. All of you will receive a link where you can download the recording. If you have any questions, please use the chat window to ask. You can ask questions during the webinar or in the end when we'll be having a questions and answer session. We'll try to answer all the questions today, but if we run out of time, we'll write a blog post in which we'll address all the remaining questions and you'll get a link to that post. You can also tweet if you want to share your thoughts and comments during the webinar. Our Twitter handle is DITAToo1, and we've created a hashtag that you can use, ontology for bots. And here is our agenda for today. We'll start with seeing how a simple conversation flow that represents a troubleshooting process for a printer can be implemented in a rule-based chatbot. One of the issues we'll have to address is how a free text that the user types can be handled. We'll discuss different approaches and understand pros and cons of each of them. Then we'll talk about approaches to handling requests if they are missing important information, without which the chatbot cannot give a precise and helpful answer. And then we'll talk about how a combination of ontologies, structured content, and users context can help us. To let you see that all we're talking about is not a pure theory, but is already supported by something that is actually working, I'll show you an example of what we've been doing here at Intwillion. And we'll end up with a questions and answer session. I hope that makes sense and we can start. Let's assume that we want to build a chatbot to troubleshoot issues with a printer. For the sake of simplicity, let's assume that only 3 issues may occur. The printer doesn't print, there is paper jam, and the print is too late. If the printer doesn't print or the print is too late, the chatbot is supposed to display a troubleshooting procedure. However, if there is paper jam, it's going to be more complicated. To retrieve the jammed paper from the printer, you need to open one of its panels. And the panels you need to open and the way you open it are different for different models of the printer. EasyPrint Basic, EasyPrint Pro, and EasyPrint All-in-One. So the answer the chatbot should give depends on the model you choose. And then we want the chatbot to ask the user whether the answer was actually helpful. If the user says yes, the chatbot responds with something like, "Glad to hear, I'm here to help." But if the user says no, the chatbot prompts the user to describe what is still wrong, parse the user's answer, and display an answer that addresses this issue. Let's now see a sample implementation of this conversation I've done for Facebook Messenger. Again, I hope you can see my screen. If you have any troubles with seeing my screen or with audio, please let me know by typing in the chat window. So this is our sample chatbot, and as you can see, it's greeting me by saying, "Hi Alex, I'm here to help you troubleshoot issues with your printer. What kind of issues are you having?" And let's say I'm experiencing paper jam. So the chatbot is now saying, which model do you have, right? Because the answer will depend on the model I choose. So let's say I'm using EasyPrint all-in-one. And now the chatbot gives me a troubleshooting procedure that I can follow to resolve the issue. And then in the end, the chatbot is asking me if the procedure was helpful. Let's say it was not helpful. I still have a problem. So I click no. And at this point, the chatbot is asking me just to enter some free text to briefly describe the issue. And let's say what I'm gonna say is it says out of paper. And the chatbot gives me a procedure that explains how to load paper into the printer. A couple of things are worth to note here. First of all, to make the task of parsing and recognizing the user's input easier, I've limited user's input by providing buttons instead of letting the user type a free and unpredictable text. This allowed me to map each button to a response that the chatbot displays. The paper jam button was connected to the next question, in which I've used exactly the same approach. Instead of letting the user enter a free text, I provided 3 buttons representing the product models. And again, each button was connected to a certain response. I used that approach again when asking whether the response was helpful. But no, if the user responded with no, the chatbot allowed the user to enter a free text. So a question is how we can now recognize what the user means. Generally, there are 3 major approaches, and of course we can use any combination of them. We can try to recognize what the user wants or the user's intent by analyzing keywords that appear in the user's request. We can analyze utterances the user types, or we can use natural language processing that includes syntactical, morphological, and contextual analysis of the user's textual inputs. With keywords, everything looks very simple. You define that if what a user typed includes a certain word or a combination of words, then display a certain answer. A problem, though, with this approach is that the one and the same keyword may appear in different contexts, which means different answers should be displayed to the user based on the context. For example, if the user says, "I'm out of paper," probably the chatbot should give instructions on how to order a new pack of paper. But if the user says, "My printer displays a message out of paper," the chatbot should probably respond with something else, maybe with instructions on how to load paper into the printer and clear the error. So keywords may work only for really simple scenarios. A more advanced approach for more complicated use cases is using utterances. An utterance is a way to express the user's intention. For example, if the user wants to print a document, there are many ways to ask about it. How can I print a document? What should I do to print a file? I want to print out a document. How can I do it? What it takes to print the document? Show me a procedure for printing the document. Show me the steps for printing the document, and so on and so forth. A problem with utterances is that you have to define them for every intent that the user might have. And think about how many intents the user may have when working with a printer. The user may want to replace a cartridge or set the printing quality or connect the printer to a computer or align a cartridge and so on and so forth. For each intent, you would need to define utterances. And a recommendation that you may get is to have at least 12, 15 utterances per intent to ensure that the chatbot accurately recognizes users' requests. In the long run, especially when you have multiple products or multiple product models or product flavors, and your product content is constantly updated, maintaining intents and utterances manually will become an expensive and error-prone process. But there is another approach, which is to use natural language processing, or NLP, to parse and analyze the user's inputs. For example, if the user typed, "It now says out of paper," your NLP engine can analyze the conversational context and realize that "it" actually refers to the printer, and "says" in this particular case, in this particular context, actually means display, because printers cannot speak. And again, based on the context, the NLP engine may assume with a certain confidence that out of paper represents the text of the message. A big problem, though, with NLP is the nature of the human language itself. Our language is full of ambiguities. Even for the modern state of artificial intelligence, with all amazing advances of the recent years, analyzing and understanding the natural language is a way more difficult task than, for example, image recognition. Look at this headline of an article published in the Time magazine a couple of years ago. The way you are probably reading it is "Pope Francis' baby steps on case," which doesn't make any sense, although grammatically, this sentence is 100% correct. From the morphological perspective, there is nothing wrong here. But we, as humans who have some background knowledge, realize that it just doesn't make any sense. It's because what it actually means is Pope Francis' baby steps on case. That is, the baby steps that the Pope undertakes. So if an NLP engine does not recognize here a noun and a verb, the result of the language processing will be also wrong. But let's make it now even more complicated. What if the user typed just "it shows an error"? And suppose we even found a way to recognize that "it" refers to a specific model of the printer. But still, this request is incomplete. It does not say, for example, what kind of error the user got. Are there any other symptoms like warning indicators on or off? So the chatbot cannot return a precise answer. The way this problem is traditionally solved is by using entities. You can think of entity as a parameter of the intent. For example, you can define that if the user asks about errors displayed by the printer, then two parameters must be provided: the message of the error and whether any warning indicators are on. So a complete request, in this case, would look something like this. It contains both parameters and let the chatbot find the right answer. If any of these parameters is missing, the chatbot will now know that this parameter needs to be requested from the user, in which case the chatbot would ask a question to gather the missing information. A problem with defining entities is exactly the same as with defining utterances. Someone has to define intents, utterances for each intent, And then in each utterance, manually label pieces of text that represents entities. That's actually, in the reality, it's a little bit easier because if you have a sufficient amount of utterances, you can train your entity extraction engine and it will learn to automatically recognize entities without you having to label everything manually. But still, in order to get there, you have to train your entity extraction engine, which means you need to have a quite good training set, which again means a lot of manual work has to be done. This is a screenshot from Lewis, one of the best language understanding engines on the market in nowadays. And as you can see, in each utterance, I'd have to label words and tell to the engine which entity they represent in order to let Lewis do it automatically with other utterances. And even the documentation of Lewis itself says that a real-world app should have at least 15 utterances of varying length, word order, tense, grammatical correctness, punctuation, and word count. About entities, it says simple entities need many examples in order to have a high confidence of prediction. And finally, we're getting to one more challenge: how to provide users with the relevant information even if they did not ask for it explicitly. You see, one of the problems of the information age is that we don't know what we don't know. And therefore, if the user is not aware of an opportunity, the user won't ask about it. And if the user does not ask about it, the chatbot won't give this information to the user that can be still valuable for the user. For example, if the user complains about light print, in addition to explaining why it's happening, why not to give the user some advice on how to save ink, or suggest the user a convenient way to order a new cartridge? Let's now see how a combination of ontologies, structured content, and users' context can help us deal with these challenges. We'll start with the definition of ontology. Ontology is a structural representation of knowledge about a domain. An ontology consists of concepts or subjects of the domain and relationships between them. Ontologies are stored in a machine-readable format, so they can be processed by intelligent applications such as chatbots. Let's see how an ontology about printers may look. As you can see, we have here different models defined, different types of the printers, connectivity options, issues that may occur, and ordering information for appliances. But it's not just that. There are also relationships defined between concepts. For example, about EasyPrint Basic, we know that it's inkjet printer because it has a relationship with the inkjet type concept. We also know that EasyPrint Basic is plugged into a computer via cable because it has a relationship with the cable concept. It also works the other way around. If we're looking for information about what printers have cable connectivity, we can track back all the relationships that the cable concept has and see that it's EasyPrint Basic, Pro, and all-in-one. The ontology also defines that all three models may have the same issues. And if the printer doesn't print, it may be caused by the way the printer is connected. So this ontology is our map. This is how we can navigate through the knowledge. However, to know how to navigate, we need to know where we want to be and what our requirements are. It's like using a GPS navigator. It has a map, but you need to say where you want to go, whether you want to avoid toll roads, whether you prefer safety over speed, whether you want to avoid certain areas, and so on. The same thing applies to the ontology. We need to get some information about the user to know how the navigation through the ontology should be done. This is when user's context comes in. User's context is a sum of all circumstances of the user in this given moment of time. Goal, user's location, products, product model, history of previous interactions, user's role, language, and so on. The content that the user should get is determined by the combination of all this and similar factors. And this combination can be very volatile. Elements of the user's context may come in all kinds of combinations. For example, the user may have EasyPrint all-in-one connected to the computer via cable and experience problems with printing. Or the user may have EasyPrint Pro that jammed paper and so on. So because the user's context is so granular, to be able to match content to each specific user's context, the content has to be granular as well. And not just that, but each content granule has to be labeled with information to which situations it's good for, like product model, audience, issues it covers, and so on. And this is when structured content comes in. Structured content allows you to keep your content granular and to have semantic markup that contains information about this content. What's important, this semantic markup is readable by machines. That means processes of retrieval and content assembly can be automated and become part of bigger processes. Now, when we have an ontology and structured content, we can connect them to each other. This can be done in the ontology itself by providing ontology concepts with references to specific pieces of content, or it can be done by adding metadata to the content, so this metadata would correspond to the ontology concepts. So now what? We've got an ontology, we have information about the user's context, and we have structured content. Let's say the user asks, the paper is jammed, how can I fix it? We run a natural language processing on that request and try to map it to the ontology. By doing contextual and syntactical analysis, we can assume that the user is having an issue and this issue is paper jam. In the ontology, we see that there is a concept representing the paper jam issue. By tracking back the relationships that this issue has, we see that it may occur in all three models. So the user's request is incomplete because the user is not saying anything about the model, the product model. But we know now what the chatbot has to ask based on the structure of the ontology. Suppose the user says EasyPrint all-in-one. If there is no ambiguity or other relationships to be followed, we can identify a piece of content meta tagged with a corresponding metadata and display it to the user. Moreover, if the paper jam issue has a relationship with a concept representing useful advices, for example, we can follow that relationship and display the user an advice on how to avoid paper jams in the future. Does that make sense? But there is another amazing thing about ontologies. If you have an ontology, some information can be inferred. Inference is a discovery of new relationships that were not defined explicitly. And here is a famous example of inference. Consider two statements. All humans are mortal. Socrates is a human. What conclusion would you make out of these statements? So you can use the chat window to type it in. So two statements. All humans are mortal. Socrates is a human. What is the inferred information you can make out of it? Right. Socrates is mortal. So what conclusion would you make out of these statements? Okay, and this is a new information, and the information about Socrates' model was not defined explicitly. We've discovered it by analyzing the existing information. A great thing about ontologies is that you can build rules on top of ontology. And there is even a special language for this called SWRL, Semantic Web Rules Language. Using this language, you can define rules for your ontology and then let new information to be automatically discovered. For example, let's say we define the following rule. All laser printers in the EasyPrint family have a Wi-Fi connectivity. Or in a bit more formal way, if printer is laser and printer belongs to EasyPrint, printer has a Wi-Fi connectivity. And now we are adding a new concept to the ontology that defines a new model, EasyPrint all-in-one. This printer is laser and it belongs to the EasyPrint family. Based on the rule that we've just defined, an inference is EasyPrint all-in-one has a Wi-Fi connectivity. So there are many ways how inferences can be used. First of all, it helps you reduce the amount of questions the chatbot asks the user. Some answers can be predicted based on the information already defined in the ontology or concluded from previous users' answers. Then, inference can help us provide the user with information that the user did not ask explicitly, but still can be interested in. There are various tools that allows you to create ontologies. First of all, it's ontology editors. And these are probably the most famous of them. It's Protege, which is an open source. It's a free software developed by the Stanford University. Fluent Editor, WordMap, Pool Party, Neon Toolkit. There are also APIs available like Gina API or OWL API that allows you to create ontologies programmatically from an external application. And at this point, you can say, okay, we already know that defining intents, utterances, and entities requires a lot of manual work. But so does ontologies. It seems like a big deal to create all these concepts and relationships and then define rules on top of them. So what's the difference? There are two things I'd like you to keep in mind. First, ontology is not just for chatbots. Chatbot is just one of many intelligent applications that can use the ontology. Ontology is a formal way to unify and standardize the knowledge that you have in the entire organization. This is like a common language in which everyone can speak, but use it for their own needs. And then different teams within the organization can use this knowledge in the way they want with the tools they want. For example, the ontology about printers can be used differently by sales, post-sale support, technical documentation, finance teams, and so on. Sales can use it to get a consistent, up-to-date information about products to be sold. Customer support can use it to understand issues that may occur in different models. Technical documentation teams can use it to understand how printers work and ensure that there are no knowledge gaps in the product documentation. And it doesn't really matter that marketing and sales have their content in Word, technical documentation has it in Data, and customer support has it online. The ontology connects all the pieces and organizes them into a standard unified knowledge. And because ontologies allows for machine processing, each team can use their own tools and business logic to process it. Plus, ontologies allow you to do something that you can never do manually, discover dependencies and new relationships automatically. And the second thing is that at least partially, the ontology can be generated automatically based on your content. And to show that all we've been talking so far is not just a nice theory, I'd like to show you what we've been doing in our research labs. I'm going now to switch to another chatbot that is much smarter than the one we see in the very beginning. Just for the sake of the demo, this chatbot was deployed in Facebook Messenger, but basically it can be anything. It does not have to be Facebook Messenger. It can be anything else. It could be Skype or Slack or your custom web application. It can be literally anything. So this is a chatbot that will answer our questions. And the chatbot is connected to the content repository that has our own documentation, the documentation for our own products. So let's see what happens if I asked it about the minimum requirements. And I will intentionally miss the product name, and we'll see what will happen. So I'm just asking what are minimum requirements. And the chatbot is asking me, just to make sure, whether we're talking about DITAToo. DITAToo is our content management system, which powers the chatbot, allows you to manage chatbot content, right? And we have our own documentation in our own repository, so you can ask chatbot about our own documentation. So keep it in mind, the chatbot is asking whether or not we're asking about DITAToo, right? So this is the only option that we're currently having. But now let's do something interesting. This is a Word document that contains documentation about EasyPrint. So this is just plain Word, plain MS Word, no structure, no XML, no data, no metadata, just nothing, just plain Word. Even it's not even styled properly. Most of the content here is formatted with normal. This bulleted list is normal, the numbered list are normal, bolds are normal, and so on. Okay, so what we're gonna do, we're going to take this user manual for the EasyPrint printer and upload it to DITAToo that will automatically convert it to structured content to data, provided with automatically identified semantic metadata. So this is the interface of DITAToo. Again, if you're not familiar with DITAToo yet, this is the content management system that powers the chatbot and allows you to manage the chatbot content. And everything here is stored in data. So what I'm going to do, I'm going to create a new folder for EasyPrint. And now I'm going to take this Word document and import it to the repository. And DITAToo will, on the fly, will convert this Word document to data. But not just that. DITAToo will use the power of natural language processing and artificial intelligence to semantically mark up the content with metadata. The first thing that it's doing is try to identify the name of the product. It retrieves it from the documentation. So it also tries to identify the type of this documentation, where it's a user guide, installation guide, a troubleshooting guide, whatever. So if it does a mistake, you can always fix it. You can always change the name or say that this documentation is actually applied to multiple products. But so far so good. Let's go just with the default settings. So now DITAToo is splitting this monolithic Word document to standalone reusable data topics provided with automatically identified metadata. And in a minute from now, you will see how this metadata will allow the chatbot build the ontology and navigate through this ontology. So it's now all the content is being uploaded to the central repository to which the chatbot is also connected. Okay, it's there now. So we can see we have here concepts. It also identified tasks. We can just run a preview. And I will show you the XML source. So you can see this is a standard valid data, but this metadata was added automatically. Now let's go back to our chatbot and ask the same question again. What are minimum requirements? And now, as you can see, DITAToo is now giving us two options, because there is a topic about minimum requirements both in the EasyPrint documentation and in DITAToo documentation. So let's say in EasyPrint, we're looking for EasyPrint. And then it gives us a topic that describes the minimum requirements for this printer. As you could see, I did not have to manually specify utterances or intents or entities, right? So they all were generated automatically based on the metadata, which was also used to automatically build an ontology that this chatbot is now crawling. But now let's do something more interesting. Let's take this this topic about minimum requirements. Here it goes. And I want to slightly modify it to add some conditional content. I'm going to do it by using Oxygen as my data editor. It does not have to be Oxygen, by the way. DITAToo is data editor agnostic, which means that you can use any editor of your choice, even web-based editors. And we also have an integrated web-based editor, so you can use that one. So this is this topic about minimum requirements that just has been displayed in Facebook Messenger. But now let's say that we want to add some more information, but that information would be intended only for a specific audience. So for example, just for developers. So no one else should be able to see it. So I will add now a new paragraph. Okay, and let's say that if you want to use the printer API, you must have Java API installed. Okay, and now I'm taking this P and I'm profiling it using the audience attributes. I'm saying that this is for developers, and save it back to the repository. And to confirm my changes, I'm going to check it in. Okay, so now let's go back to the messenger and ask the same question again. What are minimum requirements? Okay, EasyPrint. And now, as you can see, all of a sudden the chatbot is asking me whether I'm a developer. Right, again, as you could see, the only thing that I did, I just added this conditional content to the data topic. I did not have to manually add a new entity or a new utterance, right? That's happened automatically. Let's say I'm saying no. Okay, and it's just give me this topic without the paragraph that we've just added. Now let's ask this question again, and that time we will say that I am a developer. What are minimum, oops. So first of all, as you can see, so now because there was a very short time between my two questions, now this time the chatbot is not asking me whether it's DITAToo or is a print, right? It remembers the context of our previous conversation, and it assumes that it still is a print, right? So I say yes, I'm a developer this time. Okay, and now it shows me the same topic, but with the last paragraph included. Okay, so this is how we do this, and what I wanted to show you by that is that this ontology can be generated automatically for you if you use some advanced technologies involving NLP and artificial intelligence. Still, this ontology, if you want to use it enterprise-wise, most likely it has to be edited and updated because, for example, complicated semantic relationships cannot be identified automatically. This is something that you would have to do still manually by editing this ontology in an ontology editor like Protege or whatever you prefer. But it does not, of course, generate any semantic rules on top of the ontology, but it still gives you a pretty good starting point that you can use as your basis for the further development. Okay, and I would like, so basically that's the overview that I wanted to give you, and I want to leave sufficient time to take your questions. So please, if you have any questions, write them. And here, okay, so I have, so far, we've got this question: is this chatbot a Facebook app? Well, the answer is not necessarily. In this particular case, this chatbot was indeed deployed in Facebook, but it does not have to be deployed in Facebook Messenger. It can be any messenger that you can imagine, and that provides an API. So it can be Facebook Messenger, it can be Skype, it can be Slack, it can be something custom, a web application on your website, and so on. So please feel free to ask more questions. Okay, so if there are no questions, like I said, this webinar is being recorded, and the recording will be available to you. You will receive a link to the recording shortly after the session. So this is the contact information. If you have any questions, please feel free to send an email directly to me. You can also visit our website, www.intrillion.com. And thank you for attending. I hope that was useful, and hope to hear from you soon. Thank you very much. Have a great day, and goodbye. Thanks, everyone.